Okay, this one here, we've got constant acceleration, so we can use suvat. We've got an initial velocity, 4 meters per second due north, and we've got a time, and we've got a final velocity, so we're doing really well. What we haven't got this time is the acceleration, okay, though we're going to be finding that in part B. Okay, and it wants to talk about east and north for I and j, fair enough. Okay, so suvat. The things I know are the initial velocity, 4 meters per second north, which is 4 in the y direction, and 6 meters per second east, that's the x direction, is the final velocity, and the time it takes is 10 seconds there. Okay, and I want the acceleration. So do I know an equation that links v, u, a, and t? Yes, I do. It's the easiest one, v equals u plus at. Oops, I've scooted on to part B. The initial velocity is a vector. I have just done it. The answer is 6 naught, and I need to give that as an answer. I should really put meters per second after it. Okay, so v equals u plus at, sub in there, so I've got v, I've got u, I've got t. Sorry, a was the vector here, not t, so the underlining should be there. v, 6 naught, a, u, 0.4, t, 10. Now, a I don't know. Now, some people like to put an empty column vector here, or put a column vector with 2 a's in it. Why not just leave the vector as called vector a, okay? Don't necessarily feel you have to write that as a column vector until you need to. So, we have got, if we subtract the 0.4 from both sides, we've got 6 minus 4 equals 10 times the acceleration. And I want to know the acceleration, so it's easy, I can divide by 10. So the acceleration is a tenth of 6 minus 4, which is 0.6 minus 0.4. Okay, now they give the answer in stupid notation. So on this particular occasion, because it's a show that question, I'm going to humour them, and I'm going to say equals 0.6 I minus 0.4 j. Okay, and I'm going to put that in brackets and put meters second to minus 2. Okay, because that's part of the given answer. I must always get to the given answer. Okay, and I've got to calculate the magnitude. So the magnitude of a vector, remember, is just how big it is. And it's got an x bit and a y bit, and we find its magnitude by Pythagorasing. So the magnitude of A, which we write like that, okay, is the Pythagoras of the acceleration, which is the square root of 0.6 squared plus 0.4 squared. Okay, if you want to put the minus on the 0.4, which is going to vanish when we square it, you must use brackets. But this is what I've done here is absolutely fine. So 0.6 squared plus 0.4 squared square rooted, well, this is the square root of 0.36 plus 0.16. Oh, that's not a nice number. So I might as well just type the original thing into my calculator, and I get root 13 over 5, which I don't care about. This is mechanics. So I want 0.721 to 3 significant figures, and that is meters per second. Right, okay. Assuming the particle starts at the origin, find its position after 10 seconds. So I'm interested in its position. The one I haven't done yet is s, so I'm going to use s equals ut plus half at squared. And it's still saying 10 seconds. So the suvat that I've set up with a t of 10, and this is all valid. I'm not going to need that v anymore, but I'm going to use the t equals 10, and obviously u never changes, yeah? Okay, and the v would have been correct, because I'm still dealing with the same 10 seconds as I had before. Okay, so s is what I'm trying to find. It starts from the origin, yes. S is the displacement from where it starts. So I've got to be careful. If it doesn't start from the origin, I've got to add on its initial displacement. This one starts from the origin, so S is what I want. Okay, U is 0.4 times T, which is 10. Okay, plus a half times A, which I've just found. It's this 0.6 minus 0.4. I can fill it in here. 0.6 minus 0.4. Okay, plus half times that, 0.6 minus 0.4 times 10 squared. Okay, and this is 0.40. Okay, and this is, multiply that as multiplying by 100, so that would be 60 and minus 40, but I'm halving them, so it's plus 30 minus 20. So that gives me a displacement of 30 and 20. Now I've got to be careful. That's in meters. Now, did I want displacement from the origin, or do I want the distance from the origin? It says find its position, so a displacement is fine. Okay. If it had said the distance from the origin, I'd have had to Pythagoras this one too. Okay, hope that helps.